Hi, stat students. I just wanted to touch base with you on this worksheet 86B because this is kind of a big thing. We're putting a lot of things together. I'm going to just jump back real quick to this. So section 86 highlights, there is a lot of stuff. You know, we had that conversation about how sometimes you kind of muddle through and hope for the best on a test, and then you hope it goes away and doesn't come back around again. Well, that's not happening here. So section 86 is a culmination of a lot of chapters. So first of all, hopefully you know how to figure out what kind of test or interval. Remember, that's why we did those couple of worksheets. Is it a z-test for a mean because you know the standard deviation? Is it a p-z-test for a proportion or a percentage because it gives you something like 28% of students have gotten pulled over and gotten a ticket? Is it a t-test for a mean because you know x bars but you only know s, the sample standard deviation? Or is it a chi-square test for a standard deviation or a variance because it's asking you to construct an interval for the variance or to identify if the standard deviation is really less than 16 or whatever it might be. So figuring out the type of test or interval is really the hardest part. Once you get there, everything falls into place. So then, do you know how to construct a confidence interval? We just went through that worksheet, refreshing your memory, chapter 7. That's huge. Make sure you pull out your chapter 7 notes. Do you know how to perform a hypothesis test? So this is chapter 8, right? This is, again, what type of test are you using? Your hypothesis test and your confidence interval are always going to go together. Do you know how to find your critical values? So if it's a z-test for a mean, you go to your z-table. Don't forget to divide your alpha by 2. If it's a chi-square test for a variance, don't forget to go to your chi-square table. Make sure you watch out what you're doing with your alpha. So finding those critical values. And last but not least, this is the big part in section 8.6. We're putting it all together. So the first one is the hardest, I think, because once you get that, you know where to go with everything else. So let's do the first problem together on this worksheet. Let me take you back to that. So number 1, it says the average one-way airfare from Detroit to Orlando is $236. A random sample of 20 fares during December had a mean of $210 with a standard deviation of 43. So the first thing I need to ask myself, there's obviously means, right? Average, so it's means. Do I know sigma, my population standard deviation, or do I know S? Well, this whole second sentence, a random sample of 20 fares, I do that on purpose. I type out the number, so you have to actually read it. During December had a mean, so my sample mean is 210. And that standard deviation is referring to my sample, so I've got an S of 43. If I've got an S, that means I am doing a t-table for my critical value or for my t of alpha over 2 for my confidence interval. So let's perform a hypothesis test. Now we know where we're going. We're using the t-table. So step 1, my h sub o and my h sub 1. It says the average one-way airfare from Detroit to Orlando is $236, so my mu is equal to 236. Is there sufficient evidence with alpha at equal to 0.02 to conclude a difference from the stated mean? So all I can say is that mu is not equal to 236. Note to self, I can't remember if I said it in the notes, but these will always be two-tailed tests. So even if I word something weird like I do in problem number 4, make it a two-tailed. Step 2 is to find our critical value. If you are doing the p-value method, please let me know and I'll do examples this way. I'm finding that most people resort back to just doing the critical value for these problems. But again, if you like it the other way, I can definitely make that happen. So if I'm doing my critical value, that means that I have to go to my t-table, right? Because I know S, not sigma. My degrees of freedom is 19. My alpha is 0.02. If I did alpha over 2, I would just make sure that I go to the 0.01 for the one-tailed. You'll get the same answer either way. Double check and make sure that you get critical values. of positive and negative 2.539. So then step 3 is to find our test statistics so we can compare it. Remember, for you visual people, I'll just get it up here. Here's my two-tailed test. This line right here is a positive 2.539. This dividing line here is a negative 2.539. So I'm going to see where my test statistic falls. So to find my t-value, t is equal to x bar minus mu. So 210 minus 236 all over my s divided by my square root of n. So 43 divided by a square root of 20. Check your calculations. Make sure you get the same answer. Remember, sometimes the calculator is harder than the actual math or the whole problem itself. I ended up with a negative 2.704. I went to 3 decimal places because my critical value had 3 decimal places. You're going to get the same answer regardless. So I'm thinking about a negative 2.704. Zero's here in the middle. That's going to fall out here. So what decision are you going to make for step 4? It's in the shaded region. Shaded always means reject H sub O. Now somebody told me that I said for section 8.6 you don't have to do step 5. I forgot to jot down, by the way. This would be my claim, right? It says, is there sufficient evidence to conclude a difference from the stated mean? So my claim is H sub 1. So if I were doing statement 5, I reject H sub O. That means that I like H sub 1. So I would probably say something like, there is enough evidence to support the claim that the average cost of a flight from Detroit to Orlando is different from $236. So now we're going to make a confidence interval to check and verify that that supports what decision we made. So notice this is a 98% confidence interval. My alpha was 0.02. Those two will always be complements. I will never try to trick you. For some reason, if I didn't give you the 98% confidence interval, you would go back to, well, if alpha is 0.02, it's a 98%. So remember, those always add up to 1 or 100%. Here's the really nice thing about this. When we're making the confidence interval for the true mean, so it tells you what goes in the middle, right? Mu goes in the middle. We already have everything up above. So that critical value that we found in step 2 is our t of alpha over 2. It's always the same because we're using the same alpha or the same confidence interval. So when I go to make my confidence interval, I do my x bar minus my t value times my sigma over, or sorry, my s over my square root of n, so 43 over square root of 20. Remember, the other side is identical, only we add. So we do plus and minus our margin of error. Calculate that out. Let me know how you do. I went to the nearest dollar. Since it was money, I probably should have gone out one more decimal place, but I just went to the nearest, I went to the nearest penny. So I ended up having a mean somewhere in between $185.59 up to $234.41. Whoops. 234.41. So now the question is, do the hypothesis test and the confidence interval support or contradict each other? And explain. Well, I highlighted that H sub 1 up there because we rejected H sub O. We rejected that the mean is equal to 236, which means we think that the mean is not equal to 236. So when I look at my confidence interval, my question to myself is, where does 236 fall? Does that fall inside my mean? Or sorry, does that fall inside my confidence interval or outside? Right, that falls outside, which was what our highlighted H sub 1 was. We rejected H sub O, we said the mean was not equal to 236, and 236 is not a part of our interval. So our confidence interval supports the hypothesis test. The interval supports the hypothesis test. Somebody asked me if they had to write all this. Our hypothesis test, of course, was that we rejected H sub O, which is the mean is equal to 236. And it supports it because 236 is not in the interval. I would know that I messed up if 236 was in the interval, but I rejected that the mean was equal to 236. Something went wrong there. So because it was a reject H sub O, I look at H sub 1 and I say I do not want that 236 to be a part of my interval, which is true. If I did not reject H sub O, I want my mu to be equal to 236, so it's got to be included in that interval. It's not because we rejected. So that's what these problems look like. So the first thing you have to decide is what kind of test is it? Then you perform your hypothesis test, and apparently you don't have to do step 5. Then in part B, for all of these problems, you construct your confidence interval. And then in part C, I want you to explain to me, does your interval support your hypothesis test decision, step 4? It's going to be the same question. I just worded it a little bit different, but it's the same question for every single one of those for part C. So that is your practice. Remember, it's a culmination of a couple chapters here plus the critical value Z-table stuff. So we're looking at like 3 chapters of information. If you're feeling overwhelmed, you need to grab your chapter 7 notes for your confidence intervals for all the B's. You need to take out your chapter 8 notes for all of your hypothesis tests in part A. That is it for this worksheet. Get to it. Let me know if you've got any questions or concerns, and we will get those figured out.